All right, an air rocket reaches a height of 31 meters before falling back to the ground. So it's going to go up. It's going to go down. So this is one of those ones where it spends half the time going up, half the time going down. So when we want to know the total time, it'll just be, answer number 2 times 2. All right, we know that this is 31 meters here. We also know the final velocity at the top is 0. Right, so let's go from the ground to the top. All right, x, vi, vf, a, t. A is, of course, negative 9.8 meters per second squared. That's always true, right? I think our displacement to the top is 31 meters. No tricks there. Final velocity is 0. Of course, initial velocity we'd like to find, right? Question mark, right? So I think what I'm going to do is I'm going to use no t to find this, and then I'll use, I think, no x to find t. We'll see. All right, so here we go. So let's find vi. Let's find vi. Okay. I'm going to use this guy. Vf squared is vi squared plus 2ax. So 0 squared equals vi squared plus 2 times negative 9.8 times x is 31. All right. So I'm going to figure out what this mess is here. 2 times negative 9. 31. I get so I get 0 squared is vi squared plus negative 607.6. So I can put it over on this side. So I'm going to go 607.6 is equal to vi squared. And now I can square root that, right? Notice we don't have a problem with imaginary numbers because when I add 607.6 to both sides, this goes away, this becomes positive. So 607.6 raised to the 0.5 is 24 equals 24.6 meters per second, right? So here's what we know. We know that it leaves the ground here at positive 24.6. It actually hits the ground here at negative 24.6. This problem doesn't address that. These are meters per second. All right, what time did it take to reach the top? Well, this is 24.6, right? Okay, it's actually 24.649, something like that, right? So let's find the time to the top. So time, I'm going to choose to use this guy. Vf is vi plus at, because all the other ones have harder math, right? This is the easiest math. So final velocity is 0. That's 24.6 plus negative 9.8 times t. Okay, let's see. Basically, I'm going to take the number on my calculator and just divide by 9.8. That's what it ends up being. So t is equal to 2.51525 seconds. So that is the time to reach the top is 2.52 seconds roughly, right? Okay. Initial velocity is about 24.6 meters per second, right? And then total time in the air, it's going to spend this much time going up and that much time going down. So I'm just going to multiply by 2. And the total time in the air is 5.03 seconds. And that came from this, right? I just take this. It spends 2.515 seconds going up and 2.515 going down because it's got this symmetry, right? It goes up and down the same distance, which is kind of interesting. All right.